Thank you for inviting me. The talk is called Building a Distributed Data Ingestion System with RabbitMQ. My name is Alvaro, and I work for Rabbit. As he said, Rabbit is part of Pivotal. I don't know who knows what Pivotal is, but basically there is VMware on one side, then there is EMC, which is the parent company of VMware. And EMC and VMware, they had many companies like Redis, RabbitMQ, Spring, Cloud Foundry, and so on, and they decided to create a new company called Pivotal with all this stuff inside. So I work at VMware, EMC, Pivotal, RabbitMQ, you choose what. I'm co-author of the book RabbitMQ in Action. I did a simulator to teach how to use Rabbit. And I'm also writing about RabbitMQ internals, but it's mostly in Erlang. That's my contact if you want to get in touch. This is the book from Manning. And I'm come from Uruguay. You probably know that guy, I guess. There's people from Paris here. Yeah. And for me, Paris is a city I really like because it reminds me of Montevideo. That's Montevideo, and basically we copy-paste all the architecture from Paris into that city. So also it's really dirty, like Paris, so it's it has this warm feeling. And, sorry, this is the closest I ever got to Scala. I actually tried Scala. I actually tried Scala like 4 years ago, or no, 6 years ago, maybe 5 in China, because I was working there and we were doing stuff, but at the end we ended up using Erlang. So yeah, sorry, I'm an outsider. I think the second family name of Martin Odertli is Strauss-Truss. You can, I don't have facts on that. Anyway, the talk is an exploratory talk, and it's about what can be done with Rabbit instead of how to do it, because we have very good documentation on the website about how to do all the basic concepts of Rabbit. So I don't want to repeat this here, and I think everybody can just go there and learn. So I have a quick intro to what Rabbit can do, then I present a problem, a solution, and some improvement to that solution. So this is a real tweet. What even is a RabbitMQ? And so what is RabbitMQ? It's a multi-protocol messaging server. RabbitMQ supports AMQP on version 0.8, 0.9.1, 1.0. It supports MQTT, STOMP, HTTP, XMPP, and whatever MQP probably there. So, it's open source under the Mozilla public license, and it's polyglot in the sense that you can connect to Rabbit with many languages and also develop Rabbit from many languages. So I guess from the Scala world, you are used to saying this is a JVM language. In Erlang, we also have Erlang virtual machine languages like Erlang or Elixir, for example. And in Rabbit, you can also extend it using Elixir, for example. Yeah, Rabbit is written in Erlang OTP. And so what, right? I mean, a Scala conference, sorry. But the point, I mean, if you know Akka, probably you know about OTP, and it's inspired by. And OTP has a lot of patterns for high availability servers, and those patterns are all used by RabbitMQ, and the less code the RabbitMQ guys need to write, the less bugs, let's say. So when I was in China, one reason why we choose to use, oh, here it sounds better. When we choose to use Rabbit was because it was written in Erlang. We had CouchDB running in production, and it was working there in one server, one machine, and then we also saw another message queue from the JVM, and it was not as fast or memory light as Rabbit, so that's why we started using Rabbit. After that, I got more involved into the project, learned more Erlang, I ended up writing the book, and now I work for Rabbit, but that's part of history. So multi-protocol, you can choose which mustache you want. And for women, we have also fake mustache. AMQP is the default protocol in Rabbit. It's advanced messaging queuing protocol. And all the options, let's say, are there. Then MQTT is a protocol created by IBM where it's made for the Internet of Things, which has very low battery consumption and also for internet connection that can drop. That's the idea of MQTT. It's also open. I don't have a clue what it means. I know that one of the T is telemetry. You can Google that, but it's message queuing telemetry something, I guess. And STOMP is a text-based protocol. It's used at the CERN, for example, for all the messaging at CERN. They use STOMP because it's a very easy to parse protocol. It's just like header, column, value, header, column, value, double enter, body, end of the message. That's the whole STOMP protocol. So it's very, very easy to write a parser for. And we have plugins. Rabbit can be it's quite easy to extend it, provided that you know Erlang. And we have a lot of plugins, and we also build the plugins for you, so you don't need to be running Erlang or whatever to get them running. And yeah, it runs on Java, so it means there are also Scala clients, Closure. Can I say Closure in a Scala conf? I said already, it's just Erlang, sorry. So yeah, if there is a Java client, you can write a wrapper, I guess. There is no, once, when I joined an enterprise company, you can guess which one. One colleague, which is on the sales team, asked me, and how do you deploy this on a JVM about Node.js? So yeah, the J is for Java, Node, if you don't know. Of course, there is an Erlang client, PHP client, Ruby, .NET, Haskell, and so on. The RabbitMQ team maintains the Java client, the Erlang client, and the .NET client as officially maintained. I maintain the PHP one, another colleague from the Rabbit team maintains the Ruby one, and Node.js client is created by a former colleague of Rabbit. The Haskell, we collaborate sometimes with that client. So they are quite well maintained. Also, last time I did a conference in another place, and they asked me who is behind Rabbit. Yeah, we are only 3 people working on Rabbit, but actually there is a company paying for Rabbit. So it's not some guy in a garage. I mean, maybe I'm in my garage, but there is no, there is backing behind. And of course, if you are into business languages, there is also a client for that. So is there anybody using Rabbit? Yeah, Instagram is using Rabbit, Indeed, Telefonica, Mercado Libre, the health stuff in the north of the channel, and Mozilla. There are more users, but I don't know if you probably know Telefonica, right? From Spain, the south of the beginning. And they also have every telco in South America. They own everything. Mercado Libre is like the eBay of Latin America, so you can imagine all the people from Brazil, Mexico, of course, Uruguay. We are the biggest traffic source of Mercado Libre. And yeah, they're all doing all stuff in Rabbit. And Mozilla, every time your Firefox crashes, if there is somebody still using Firefox, the crashes go through Rabbit. So we are the NSA in your Mozilla crashes, basically. And the New York Times, they deployed this year the Rabbit architecture in Amazon. And they had 500,000 users concurrent when they deployed, and they didn't have any problem. And the guy behind this architecture, he's a pre-epoch guy. He started working in the 60s. He had lessons with Distra, among other things, and he shares his knowledge in the RabbitMQ mailing list, so it's very interesting to actually read the blog post from that guy. He told me, I was at the first meeting in New York when they started discussing relational databases, or relational algebra, or whatever. So he has some experience. So enough of marketing. And now I want to show you how RabbitMQ works, and this will be interesting because I need to use my hands and the microphone. So I have this simulator, which I hope you can see what's there. And I have JavaScript, yeah, bar that, this, but don't look at that. You will have a collapse. And not this here. So the idea when we do messaging is to have a producer that sends data to a consumer. So you want to get the data there, but to do that you need an address. Which in RabbitMQ, the address is called exchange. So you can grab the producer, you can send data, and the data just ends there in the exchange. What's the problem? Is because we don't have a queue. If I bind the queue to the exchange, then the messages arrive to the queue. So finally, I can subscribe the consumer to the queue, and then the messages will arrive there. So we publish to the exchange routes to a queue, and from the queue goes to the consumer. If we want to speed up the process, we can add more consumers. And then Rabbit will take care of doing kinda round robin to the consumers. So you may wonder, why do I need an exchange? Why cannot just send the message directly to the queue? Because the exchange is just a router. I can have more than one queue bound to the exchange. And if I send the messages, they will be distributed to both queues. But what's the point? The exchange, or each exchange, implements a routing algorithm. In this case, it's a direct exchange. You can see direct, fan out, and topic are three kinds of exchanges. The direct needs to match the routing key here, or binding key, exactly. So if I have XDF, I change, and I send a message with without a routing key, it will go to the queue down there, because that queue doesn't have a routing key, or an empty one, actually. But if I change the routing key in publishing, then it will be routed to the other exchange. That's the direct exchange. It's kind of saying like select from queues where binding key equals routing key. There is no SQL behind because Rabbit doesn't use an SQL database, but that's the idea of the query. But if I have a fan-out exchange, I can do typical PubSub, because with fan-out, we don't care about routing keys. So whenever you see broadcast or PubSub, you can do it with fan-out. And if I choose topic, the idea of the topic exchange is to use routing keys, but to also be able to use patterns. So I can say that I have a binding key, let's say server1.application1.info. So if I send a message with that routing key, it will just go there. Nothing so different from a direct exchange. But the point is, I can tell this other queue to actually listen on every error message. So I can use a star here, like that. And when I publish, I can send error, for example, and it will go there. And the key of this pattern is that we have words that are separated by dots, so I can have a star on these things. And if I use a hash, sorry. I think hash is forbidden in French, the Twitter hash. I read some news that people couldn't say that English word. I don't know if it's true. Never know. So if in the binding, I can do like hash, error. And what this will do is like if the message comes from server 2, it will go there. If it comes from application 2, it will also go there, and so on. So we can use all these patterns to decide to which queue the message will go. And that's with the topic exchange. So, to recap, we have producers that want to send data to consumers. To send data, we need an exchange, which is a router. Think of the exchange, I don't know here, but in Switzerland, I live in Zurich, when you go to the main station, you can press, like you're greeted by a computer and you can say, I want to buy international tickets or local tickets. If you click on international, you will get a ticket for the international queue. If you click on local, you get a ticket for the local queue. That's your exchange there. And then all the queues are the queues that we have there, and the consumers is the people selling you tickets, basically. So that's the whole idea of what you can do with this MQP model. Do you have questions up to here? No? Okay. So, this is what you can do with Rabbit, and you can, of course, you can combine, you can make, if you want to do an RPC, you want to send a message, and when this process finishes, you want to send the reply back. You can do that using exchanges. This one can also publish a message, route it, and get it back to this one, which also needs to become a consumer. So you can do all kinds of mixes. You can do also pipes and filters, where you have many filters, and then they read from one place and they publish to the next filter in the chain, and so on. I mean, all these messaging patterns. There is a book about enterprise integration patterns or whatever. So this simulator is not only for doing this kind of graphics. You can also import stuff from Rabbit and see your architecture there. And, for example, debug why your message is not traveling the whole way through Rabbit. You can export what you design here. You can click export and put it into Rabbit, for example. And I know companies that use this to teach to people that they hire. And they also, you can also put this only in play mode, where you design everything, you export it, and then you can just load a player, and then you have your documentation saying this is how our architecture is working, and just have the player showing all the stuff, like all the message flow points. But you can check the website. So that's Rabbit. Now the problem is, let's say we have something like this, where we have applications running in Ireland, Singapore, Brazil, and the United States. And each of these apps is collecting data and doing some stuff locally, but now you need to send data, let's say, to one location. Maybe if you read the news, you see this pattern also. Data flying from all over the world into that country. This is a good thing of being in Europe or in South America. We are free to speak. Cut there. So you want to do that, for example, and how do you actually do it? You could, I mean, on each of these areas, you have Rabbit running, Rabbit, but you need to send that. So first, what is running on each of these locations? This is Erlang, sorry. It could be any other language, but in Rabbit, when you connect to Rabbit, you just get a connection using, of course, you can use password, users, and more options, but this is just an example. And you get the connection object, and then you open a channel. So in Rabbit, we have the concept of having only one TCP connection, but many channels. So you can multiplex the connection, and there is a state maintained per channel. So if you do an ACK, the ACK needs to belong to the channel where you receive the message, for example. Anyway, you have the connection and the channel. Then we can declare an exchange called events of type direct. And as you can see, the commands, they go on the channel, not on the connection. And then we send, this is why people love Erlang, the record syntax. This is one of the best things. So you have the channel, you do basic publish, an exchange, to the event exchange, and the message has some properties like persistency, whoa, magic numbers, and payload is hello federation. So that's just publish the message. And when we want to consume data, we have connection channels, all the same. We declare the exchange, we declare the queue, and we bind the queue. So this, we saw it already, we have a queue, and then we call on the channel, queue bind, and we get the thing going. And then we subscribe. We send basic consume to Rabbit, meaning I want to get messages from that queue, and I'm not going to acknowledge the messages. So Rabbit, as soon as it sends a message, it just forgets about the message, doesn't need to keep track of anything. And then this is just Erlang. We receive a message called basic consume, okay, yeah, okay, then we just loop. This is the most basic Erlang. I'm not using OTP here. You should use OTP and blah, blah, blah. And then the loop is very simple. We receive, so we block whenever we get a delivery from Rabbit. In this case, that shows echo the message body, and then loop again. That's, I mean, if you ever learn Erlang because somebody told you it's functional programming, they lie to you. Erlang, functional programming and immutability is part of the requirement of the design of Erlang to have a concurrency-oriented blah, blah, blah language, but it's not a functional language. Well, I would say in the sense of Haskell or Lisp or Scala or whatever. It's more like, yeah, you have to use functional because that's the way to not have share state and blah, blah, blah. But if you look how you program, it's not really, I believe, in a functional style like I would see in Haskell, for example. Anyway, that's Erlang. So we have a producer, we have a consumer, and a solution could be that we just create another, I told you that you can have exchange and put many queues bound. So you can have a new queue where you just grab all the messages and you send it to the remote server. But what can happen? What happens if the remote machine is offline? What do you do? How do you prevent unbound local buffers? How do you prevent that data doesn't start collecting on your machine in Brazil, let's say, because it cannot connect to the US? There is a World Cup and there's too much traffic in that network link, so you cannot send data up. What do you do? How do you prevent message loss? What happens if your link just went down or the remote server went down and you send the message over the network and you have no idea if it arrived to the remote destination? How do you prevent unnecessary message replication? What happens if the messages are not needed in the remote server, like they are too old? In messaging, there is always the concept of data becoming stale because usually you want recent data. If you're working with events, you don't care that Cavani was sent off because you did this, because on the next game he already did that, so the first red card of Cavani is already of use, right? I don't know if you follow soccer, but I think it's a compulsory in Uruguay to follow soccer. So. Anyway, is there a better way to do this? Of course, I'm here to sell you RabbitMQ, and with using Rabbit, there is a federation plugin. And federation is made just to do that, to do replication across many clusters. You can mix Erlang and Rabbit versions, and the idea is to support network partitions and to be able to tell what you want to federate. You don't need to federate everything. You can just say, I want this and not that. And you can build topologies like this one. You can have a upstream server sending data to all the other Rabbit brokers, and you can decide how many hops, how many times the message will travel to keep going in this cascade, let's say. You can have like a circle of replication if you want, and there you say max hops 5, so if the message doesn't keep looping around. And it's just a plugin. Internally, it's just using queues and exchanges, and you configure it using parameters and policies. This is stuff from how you configure RabbitMQ. So you can enable the plugin. You can enable also a management console where you can click around, and then you will create an upstream. What is an upstream? If you have a river, the water flows from the upstream to the downstream, right? The same idea is in Rabbit. You have your upstream server where the data will flow down to the other machines. So here we are telling Rabbit that there is an upstream called my upstream, and that the URI to connect is MQP blah blah blah. You can of course have your proper parameters there, and that the queues on that server, if they are not used for 1 hour, they are expired, because we don't want to just keep piling data. Then we tell Rabbit, add a policy. So this is a parameter, I told you, parameters and policies. Then you add a policy that applies to all the exchanges. The policy will be called federate me, and it will federate all the exchanges whose names start with AMQ dot. Because if you have a problem, you solve them with regular expressions, right? And yeah, that's, you tell them from where to pick the upstream. That doesn't really matter now. So with those two commands, RabbitMQ will set up this. So before the federation, this link here doesn't exist. This is your machine in Brazil, let's say, and this one is the one in the US. So here we had a publisher sending messages to an exchange, and the consumer getting messages from the exchange or the queue. Then in the States, we have also a publisher and some queues getting messages from that exchange. When we add federation, we have this link that mysteriously starts sending messages to this exchange, but this queue here has no idea that these messages are not coming from here, they are coming from here. It's totally transparent. You don't change any code, you don't do anything, you just enable the plugin and tell it federate this or that exchange. So Rabbit will start doing this replication by creating a queue here, the upstream queue, and this queue, depending on your settings, is how it will replicate messages. And we will see this part now. So to configure federation, you should set a parameter, which is a JSON object, which, for example, could have a URI, a prefetch count, reconnect delay, ACK mode, and whatnot. So some of the things you can configure: expires. This tell Rabbit, if the queue on the upstream exchange is not used for n milliseconds, then you can remove that queue. You don't want messages to just grow on the remote server. Message TTL. If the message on that server is older than n milliseconds, then don't replicate that message. Max hops, how long you want the message to jump from server to server. ACK mode, you have onConfirm. This means RabbitMQ has a mechanism called confirmation, which you send a message and you can ask Rabbit to confirm that it actually brought the message to disk, or that it replicated the message to other servers. If you are using mirroring, like queue replication, this is not the same as federation. So you can tell this ghost queue that I told you that you see here, this one. Here there will be like a consumer pulling messages from here and send it to the other machine. When are those messages deleted? That's the ACK mode. On confirm, the remote server told me they are written on this. On publish, the consumer was able to write the message to the network. And no ACK, it means as soon as the consumer gets the message from that queue, the message is gone. I call the living la vida loca version. Like that one is the fastest one, but you could of course lose messages. Then you have the URI, which you can read more there. The slides will be online somewhere at some point. And the configuration, you can apply it via RabbitMQ CTL, as I showed, HTTP API, or the management interface. Management interface is just a browser application, and the HTTP API is a REST API that Rabbit has that you can use to configure the whole Rabbit, like add users, set permissions, add queues, exchanges, bindings, remove stuff, delete messages from queues, monitor memory usage, CPU, file descriptors, whatever. So with federation, we just got for free that replication thing. But up to here we have the problem solved. All the stuff I'm mentioning from now is if you need more scalability. And there are some things that you need to know in order to have a faster Rabbit, let's say. And one of them is how to get the most out of Rabbit with something which is called quality of service or QoS, basic QoS. So when you have Rabbit and a queue, you will send message. Rabbit will start sending messages to your consumer, and some time when your application logic takes 4 milliseconds, it will send an ACK back to the queue saying, I already processed that message, you can delete it. But you can see that the latency is 50 milliseconds in both directions. So you need to be able to tell Rabbit, because I can have a prefetch buffer on the consumer, you can tell Rabbit, instead of sending one message at a time, please send me 50 or 100 or whatever. But this will depend on your latency or bandwidth and your application logic, because you can run many of these consumers, as I showed you already. So do you really want that your messages are not sitting in this queue, but they are sitting on the prefetch buffer? Maybe not. Maybe you want the messages on the other consumer. There is an algorithm made to calculate all the stuff, and it's explained on this blog post. So you can really see or set this prefetch buffer, which I will explain soon. So for that, I have also another simulator called the BasicQueue Simulator, where we have a queue, and let's say, come on, Safari, thank you. No? Yes. So I can add messages to the queue. I don't know if you can see it, but there I have 500 messages. And then I will have a consumer that has 100 milliseconds per message and a buffer of 5 messages. So I added 4 consumers to the queue. What I can do now is start sending messages, and you will see what I mean by the prefetch buffer. So this consumer, all of them have a QoS of 5 messages. So now in the buffer they have 4, 5th message, and then because the buffer is full, Rabbit picks the next consumer. That's why I told you it's kind of run robin. It's not really run robin. So the message will go to the next consumer. When there are 5 messages, they go to the next one, and so on. And then if I keep trying to deliver messages, they won't go anywhere. Why? Because I need to ACK messages. So the consumers, they ACK the message to Rabbit, and then Rabbit can keep sending messages. There, then one down there, and there. And of course, the one on top, because it hasn't ACKed any message, still doesn't get more messages. So with BasicQueue, what you can do is really set, based on this latency here, your QoS setting, maybe 5, maybe 100, maybe 1,000, depends on your memory and so on. And then on the speed of processing, and then you can start ACKing messages back. And also you can ACK messages as a batch, for example. So that's like an overview of how BasicQueue is working on Rabbit. And in that blog post, you can see more into details the theory on how to calculate what you could use, what values to use. And I plan to also this is already open source, or not really because it doesn't have a license, but it will be open source soon. And what I want to have with this simulator is that you can tell the simulator, in my production application, I will have an ingress of 1,000 messages per second. My consumers will take 50 milliseconds to process each task. And then you can really see how many consumers you need to keep the queues as empty as possible. Because the idea is to have your messages where they can be used. If you ever went to a supermarket and you see there is a cashier empty and you're just waiting in a queue and you're telling why they don't put somebody on that cashier, that's queuing theory. The same thing happening here. And like the basic equation of queuing theory, which for me was kind of revelation, not like mystical, but similar, is that what's the whole idea of queuing theory? If you look at this equation, you have a mean arrival time, it means how many messages you are getting per second, a service rate, how fast you can process the messages. And this is obvious, but it's probably one of the main sources of crashes in production is that mean time is greater, arrival time is greater than service time. So your queue lengths start going to infinity over time. If you have not enough machines and you have way too many users in your website, at some point it will crash or people won't get their web page. So my revelation was that queuing theory, all the equations and what you can do and do not, are made so you don't have any queues. The idea is that you optimize as much as possible so your queues as short as possible. So for me that's quite cool that they have a whole theory trying to minimize queuing, and it's called queuing theory. And in that blog post I explained what can you do with Rabbit to prevent that the queue keeps growing and growing and growing. And I recommend this book. It's called Performance Modeling and Design of Computer System, Queuing Theory in Action. And this book is really cool because it shows many techniques of scheduling and queuing where, for example, when I was in China, we had a website that had a lot of users from Germany. It was making an online dating platform. You can imagine people do that stuff. And yeah, if I would know some of these algorithms back then, it would have been really cool to actually scale using this theory, because the idea of scheduling and queuing theory is that you scale with the same resources, that you don't put more resources to scale, that you just learn how to distribute jobs so your resources are better used. And in web applications, for example, that's not, I wouldn't say easy to do, but you can know that if you have a page that is cached, completely cached, that work will be very easy to run, very fast. But if you have an application, a page that you need to calculate all the time, for example, a search or something like that, that will be slow. So based on those parameters, you can really design how to route traffic to your machines, for example. And RabbitMQ implements some of these scheduling algorithms. I would like that it will implement more and that we can add plugins to implement maybe a scheduling algorithm that works for us, but maybe it's not the best for everybody, like what Rabbit has out of the box, but you could add your own and say, I want this particular kind of scheduling. Anyway, knowing all this stuff, let's say we want to scale the setup. And just one detail, when I mention scale the setup, keeps these numbers in mind. So this is Rabbit using the Java client. Of course, it's a benchmark we wrote. Never trust a benchmark that you don't write yourself. Or don't trust other people's benchmarks. But this can be done with the Java client, this kind of numbers. You can just go and read that blog post. I don't want to repeat it. So, when I mention these problems, keep in mind those numbers. If you don't have such traffic, you probably don't have these problems. So what's the problem? In Rabbit, the context of a queue, they live on the node where you declare the queue. You can have a cluster of Rabbit nodes, but when you do queue declare in node A, the queue contents will live in node A. You can enable replication in Rabbit, not the federation, but another kind of replication. So the contents are distributed to more servers, but you still have kind of a master node. So a cluster can access a queue from every node, But at the end, the queues are Erlang processes. And Erlang processes are tied to one core. Which means if you have a new server with 48 cores, or whatever number of cores, and you buy one with 128 or whatever, you won't get faster. Of course, you will get more concurrency, because Erlang processes will be for consumers, for queues, for channels, for connections, for reading from the network, and I guess you know how Erlang works with all these processes. Millions of processes per virtual machine. So yeah, you will have better concurrency, but at some point you will hit this limit. Again, lot of traffic. I'm not saying 1,000 messages per second. That's nothing. And so if you add more nodes, doesn't really help. So a solution could be sharded queues. The idea of sharded queues is that you have an exchange that is doing modulo hashing or consistent hashing and queues. And when the messages arrive to the exchange, they partition the stream so you get scalability, let's say. So you have a stream of messages, messages will arrive to the exchange, and then the plugin will create some queues for you where the messages will arrive. In this case, it's called images. So the plugin, what it's doing, it creates like a virtual queue called images, where you can just consume. You don't care if there is one queue or 20 queues behind. The plugin will take care of all that for you. So if the content, when the plugin declares queues, it can have the same queue, but in one node, in another node, and in another node. Or you can have, let's say, 4 on each node, and so on. And the exchange will do the partitioning. So you will have some queues created by the exchange, like node name.queuename.index, like 1, 2, 3, blah, depending on how many per node you want. These queues will be bound to a consistent hash exchange or partitioner exchange, and it's all transparent to the consumer. These are just a virtual queue name. Node name, you don't care. Index, you don't care. You just care about queue name. So that's sharding. It will just distribute the load across the cluster and across cores as well. And if you need more scale, there is also federated queues, which what they can do, is to load balance messages across the queues when you tell them they are federated, but only when needed. So if a queue, which is federated, has consumers, and these consumers cannot keep up with the amount of messages coming to the server, but in another node, Rabbit knows that there are consumers doing nothing, Rabbit will start sending messages to those consumers. I don't know if you know, I think in France can be similar to Uruguay. In Uruguay, when the public works is fixing a street, there is a guy fixing the street, and 5 guys looking at him, like monitoring that he's fixing the street. So Rabbit will prevent that, basically. That's the idea of this whole thing. So to federate the queue, you have the same upstream idea and the same regex applied to queues, policy, blah, blah, blah. Exactly the same as for exchanges, but you should say applied to queues. So that's federation. Just those 2 commands will get you this distribution of load. And just to end up the talk, with Rabbit, what we can do is to get data using many protocols like MQP, MQTT, Stomp, or HTTP, or whatever. We say this. And with federation, you can distribute data globally. And the advantage is that you don't change your application code. It's a picture in Chinese. 2 minutes. And we can scale up using sharding and load balance using federated queues. So, credits, the pictures of Cavani, and I don't know where I got them, so they will be gone probably at some point. Do you have any questions? Wait.
I don't know much about MQs. So how would you say that Rabbit is better than competition? Like, I don't know, Kafka or something like that.
So the question is, how can I say if it's better than the competition? And there was a project mentioned. I don't get into public debate about which is better and what not. I have read papers of that one. And there is a lot of things that are actually true. There is, as I say, write your own benchmarks. Yeah, I don't want to get into there because I know it's not fair. And sometimes vendors claim stuff that is a nice view from the truth. And you can just see our documentation. In our documentation, we tell you what happens in a network partition. Actually, you can see the blog post from Afir on how RabbitMQ fails if there is a network partition. What are the failure scenarios, for example? And we don't lie about that. We will tell you straight away. We will tell you straight away that Rabbit can do some performance, and we will tell you straight away, don't use Rabbit in this way. That's all our documentation. What other vendors want to do is not our problem, and I don't want to go there because everybody claims that Erlang is the best language, and if I'm here, Scala is the best language. So. Another question?
So maybe, so number one feature of Rabbit, what would it be in your...
From my point of view, the advantages of Rabbit is that it supports NQP, which means there are clients for a lot of languages, one thing. Then the many protocols that you can have MQTT on the, for example, on the iPhone, the Facebook chat uses MQTT, for example. Not Rabbit, but it's using MQTT. So you have a wide variety of platforms where you can run a Rabbit client, let's say. And then all the exchange routing that gives you a lot of flexibility when you implement different scenarios. So if you want to just throw data at it and have one consumer, then, as they say, just open a socket. But if you need to be able to tomorrow, let's say you are resizing images, and then you want that whenever there's a new image, you also send an email. In Rabbit, you just plug another queue to the exchange, and you have that flexibility, for example. So, from my point of view, is on the flexibility side of the options you have, or even with plugins. You don't like how the exchanges are working, you just create a new exchange with a different algorithm. And a routing algorithm is like 5 lines of development. So it's quite simple. No problem.
Any other question? Okay, I guess we could. Thank you, Alvaro.
Thank you.